Okay, from this session now we'll be moving on to question number 3. The question 3 says that the average hemoglobin concentration in the healthy population is claimed to be 13.5 gram per deciliter. So first of all, here they have clearly mentioned that they are talking about population. So population mean can be denoted by mu, and mu here given is 13.5 gram per deciliter. A laboratory technician measured the hemoglobin concentration in 12 randomly selected individuals. So now the sample size here which they have given is 12. Now you already know the n is lesser than 30. So z test cannot be applied and obtain the following values. Now there are certain values given here. You can say that these are the values of x. These are 12.8, 13.1, 14.2, 13.9 and so on. So you can easily write it in a form of tabular form. Okay, so the x values were given. Now what can we do? We have to find the mean first, whatever the mean comes out to be, and then we'll do x minus the mean. We'll calculate the each value. We'll also do x minus the mean and its square. So we have to square each value, and then we have to at last summate the entire thing whatever has been given. That is summation of x minus x bar and its square. So once this has been done, now what can you be doing after this? So now we have to first of all work for the standard deviation and the standard error. So how do we calculate it? So we know that standard deviation here is the root of variance. We denote it by sigma only. Now variance formula comes out to be the summation of x minus x bar and its square upon n minus 1. Now once you calculate the value comes out to be 3.0568. So you have to put it here, and the total n was 12. So 12 minus 1, so it is 3.0568 upon 11. This comes out to be 0.2779. So this is the value of variance. Now standard deviation is root of variance, so it is root of 0.2279 and it comes out to be 0.52. Now you have to calculate standard error. Standard error is nothing but standard deviation upon the root of n, because only a single group we are working upon. So this will be the formula for this. See, the formula for standard deviation always change, standard error will always change even for the standard deviation. So you have to learn them by heart, that if there are two groups, if they are paired, then what would be the formula of standard deviation and standard error. If they are unpaired, then what would be the formula. If there is a single group given, then what would be the formula. So it depends. So it will be equal to 0.52 upon root of 12. Now let's leave it here only. Let's now calculate the t value. The t value is the sample mean minus the population mean upon standard error. So it is sample mean, that was 13.52. Once you calculate, the x bar value comes out to be 13.52 minus population mean, that is 13.5, which was given already in the question, upon standard error, that is 0.52 upon root of 12. Calculate the value comes out to be 0.13. Now you calculate the table t value also. What will be the value of t from the table? So you need to know first of all the degree of freedom. It is 12 minus 1, so it is 11. And at 95% confidence level means you have to find it at alpha equal to 0.05. So the t value for the degree of freedom 11 and the alpha of 0.05 comes out to be 2.201. Now since here your value comes out to be lesser than 2.201, clearly you will accept the null hypothesis. Now what can be the null hypothesis? You have to determine whether the sample supports the population claim at 95% confidence level. So let's take this as the alternate one, that sample is supporting, and null says that does not support. Now since you have accepted this null hypothesis, so you will say that no, the sample does not support the population claim at the 95%. confidence level, because you are accepting the null hypothesis and rejecting the alternate hypothesis. So this is how you will solve this question. Let's move to the next question. Next question is that a sample of 9 fish. So first of all, the sample size given here is 9. So again it is a t-test somewhere. From polluted river shows the mean gill length. Sample mean is given 6.8 centimeter with variance means sigma square given is 2.25. You determine at the 95% confidence level interval. This time you have to determine this for the population mean gill length. Means you have to actually find a range for the population mean which can be statistically significant at 95% confidence level. So means you have to find a range for mu this time. So this is entirely different question. For finding the range of mu, or for finding this interval, what you need to do is you need to use this formula, that is x plus minus. Why plus minus? Because you are finding a range from the lower number to the higher number. So plus minus t, you have to calculate the value of t, multiply by the standard deviation upon root of n. Now from here you can calculate the value of standard deviation. It comes out to be 2.25 and its root. So it will be 1.5 approximately. For the value of t, you have to first know the degree of freedom. This value is the t table value. The degree of freedom here is 9 minus 1, that is 8, alpha 0.05. So the t value at 0.05 for the degree of freedom 8 from the table comes out to be how much? So it comes out to be 2.306. Now you will simply put the values here. So x bar, or the sample mean, comes out to be 6.8 plus minus the t value comes out to be 2.306 multiply by the standard deviation, which comes out to be 1.5 multiply by, sorry, divide by root of n, that is root of 9. So this comes out to be 6.8 plus minus 1.153. So it can have a lower range of 5.65 and the higher range of 7.95. Means the population mean gill length, the interval for this population mean gill length will be in this range. So this is how you are going to solve this question. Moving on to the next question. A nutrition scientist studied the relationship between the protein intake and the body weight gain in the laboratory rats. So here you have the protein intake values, and then you also have the how much weight you are gaining. Now you can clearly observe from this data that the protein intake remains constant, and through the increase in protein intake you are increasing the weight. So the x is the constant variable or the independent variable, and y will be the dependent variable. So you have to construct the regression equation. You know that regression equation will be equal to y equal to a plus b x. And now for this you have to first of all calculate b. B will be for yx. So I won't be solving, I'll be just telling you the formula. It will be x minus x bar multiplied by y minus y bar, and the summation of this column upon summation of x minus x bar and square. So once you calculate this, you will find the value for b. Now for finding the value of a, what do you know, or how do you solve it? So y mean will be equal to a plus b yx multiplied by x mean, like this only I'm writing here. So a will be equal to y mean minus b yx in bracket x mean. So whatever the value of a comes out to be, we will be finding. Then you can simply put here, and you know that when the protein intake becomes 12 gram per day, means you have to find the value of y at this value of x. So this can be easily solved. Moving on to the next question. Question number 6. The question number 6 is that a geneticist expected a Mendelian phenotypic ratio of 3:1. So it is the uh, test of independence only, chi-square. You are getting the following observations for the dominant and for the recessive traits. So observed frequency here is 126 and 34. First of all, we will calculate the expected frequencies. So 3 is to 1 ratio we are finding it. We are finding for 3 is to 1 ratio. We have to test for this. So first of all, we will total it. The total comes out to be 160. Now we will be applying the formula for calculating the expected value. So it will be equal to 160 multiplied by 3 by 4 because the 3 ratio is there. And here because it was 1 ratio, so it should be 1 by 4. So once you calculate it, it comes out to be 120 and it comes out to be 40. Now you will do observe minus expected, then you will do observe minus expected square, then you will do observe minus expected square upon expected, and finally you will summate the two values of observe minus expected square upon expected value. So the final answer comes out to be 1.2, and this is your chi-square value which you have calculated. Now we will see from the table. First of all, we should know the degree of freedom. Degree of freedom is, because there are two sets given here, so 2 minus 1, it will be 1, and the alpha is 0.05. So the chi-square value for the degree of freedom 1 at 0.05 level of significance from the chi-square table comes out to be 3.84. And since your calculated value smaller than 3.84, you will be accepting your null hypothesis. So what should be the null hypothesis? You were supposed to examine whether the observed data agree with the Mendelian ratio. So null hypothesis is that it should not agree. And the alternative hypothesis should be that it should agree. Okay, wait. It is just the reverse. Null hypothesis should be that it is agreeing, and the alternate hypothesis should be that it is not agreeing. So by calculating this value, what you can say is that your chi-square value shows that the observed values are agreeing with the expected values. So that is somewhere or the another the ratio of 3 is to 1 is followed.